here from Navati Tuned, and today we're going to be talking about spark plugs and why they are important when you are tuning your car. This video is not just specific to the B48 and the N20, it is effectively usable in all the other engine platforms, but today we're going to be talking about spark plugs, and we're going to go into a little bit of detail. Hopefully I don't bore you guys, but without further ado, let's jump straight into it. Okay, so let's get started. We'll start off with the basics, right? This is clearly a spark plug. This is what it looks like. But what is important when we come to spark plugs? It is a consumable item. It does need to be replaced. It does have a service life, okay? They don't last forever. They can break. Now, when it comes to performance automotive applications, where do spark plugs become a problem and when do they need to be upgraded, right? So spark plugs have a thing called a heat range, right? The heat range is basically how long ceramic you can see meets or joins with the surrounding thread, right? If you've got a really long and narrow bit of ceramic, right, and it doesn't join back to this body or the threaded area or even this part of the body of the plug here until further down, it means it's a hotter plug. And that means that ceramic will get really hot, right, and will take a really long time until it can disperse the heat into the plug body and then from the plug body into the cylinder head, right? If the ceramic is a colder plug, right, the ceramic will meet the body or the threaded area of the plug sooner. And the benefit of that is that that heat only has to travel from here to say here, and then the body will then transmit that heat into the cylinder head, and that's how you remove heat out of the plug. If you're starting to see a bit of discoloration in the first few lines of threading all around the shell here, the shell which is just above the threads but it's metal, or you're starting to see heat fatigue or related problems around the ceramic, right, that's definitely when you want to start looking at a colder plug. Now, when, in terms of power and boost, look, it is a bit, depends on the engine. Look, on the S55 and N55, people run these plugs and don't have a problem. But the difference here is that we're running in a 4-cylinder engine, it's under more boost, it's under more stress, right? So, of the engines that were making high power and running these plugs, we didn't really see any problems with them. However, those engines really didn't run for very long, and I say that because they were tuned, they made a dyno figure, and then we just never heard from them again. They just disappeared. I don't know if the engines are running. No one really knows what's going on there. But when we got to Ken's engine, we realized that there were some downfalls of this plug when running consistently, high 30 pounds of boost, right? It's a good plug. It's an 8 heat range plug from NGK. Now, not every single spark plug manufacturer has the same heat range chart, so there are actually conversion charts of what an 8 heat range in NGK, the equivalent Champion plug might be, or the equivalent Denso, or the equivalent Brisk, right? There are conversion charts. When we start running high power and high boost pressure, the area of the plug that we care about the most is this top section, right? We need it to be a colder heat range. It needs to be well protected from things like pre-ignition and detonation, because that will cause this ceramic to begin to fail. And if that ceramic falls off, it does not combust. It will embed itself into the piston or cylinder head or wherever else, right? So we want to protect that ceramic, right? The spark plug gap also plays into it. The material used for the ground strap and the electrode, that matters. It even matters too how thick the electrode is, because that can change the ignition pattern. So there's a lot of importance up here. Everything down this end is pretty generic, okay? I'll get to this end later, but it's really simple, right? Now inside here, there is a resistor. Now there's a reason for it. There needs to be a resistor because without it, you can affect the electronics in the car. Virtually every plug has a resistor, but for BMWs, it's a 5K ohm resistor that's inside here. You can't see it. In their plugs. So whenever you're looking at plugs, make sure it's obviously an approved plug. Now, I've gone through a wide range of plugs to work out what could work and what won't work in the BMW world, so we can save people the pain, right? Now, this is an NGK 97506 plug, right? Stock N20, stock S55 in most cases. It's an upgraded plug for the N55, okay? Now this did replace, there was a slightly prior version. As you can see, we've got SIL-ZK-BR8D8S. There was an 8E, 8S. That was the first generation of this plug. It's been replaced with an 8D, so it's irrelevant in this discussion. But manufacturers make changes to plugs, and I'll show you why, because I've got some great examples in a second. The look, the N20 97506 plug, it's pretty good. However, to be honest with you, from my experience, I really would not be running this anything over 26 pound of boost, right? I wouldn't be using this plug. It's not going to last long. Now, when you gap the plug, because the factory gap in this is 31 thousandths of an inch or 0.8 millimeters, all right? So that's the factory gap. Pretty much anyone who uses this plug will gap it down to a 22 thousandths of an inch. And that's fine for stock coils. It does hurt your idle a little bit. It might not be as efficient. You might get a little bit of a rough start, especially if you go lower than 22 thousandths, say like 18 thousandths of an inch. But if you're running an upgraded coil, you don't need to gap the plug. You can actually leave it stock, because the whole reason why you gap the plug is because the air resistance under high boost pressure makes it really, really hard for the plug to jump the gap and complete the circuit, right? Makes it very, very hard in here for the electrode to bridge with the ground strap. So you close the gap, which allows the spark to more easily jump the gap and ignite the fuel and air in the cylinder, right? If you run a higher output coil, it effectively solves that problem for the most part, all right? Sometimes you may still need to gap the plug. It just depends on how much compressive force is in that cylinder working against the energy coming through the plug at the top, right? So gapping is not a bad thing, but it does have some downsides. To go into a little bit more detail, right? What the spark plug manufacturer's thread reach is typically defined as, and I'll chuck a diagram up somewhere just so we can get a little bit of a clearer picture, but usually, and it does depend because sometimes each manufacturer may differ and sometimes even the way that they measure it can be differed, but usually when they refer to thread reach or plug reach, they're referring to the base of this here, not the washer, the base, right, up to the top of the threads, right? Everything past the metal threads to here is called the metal shell extension, and how much of that extension does matter, and I'll explain a bit more when we get to the B48 plugs, right? Then you've got your ground strap. They've got different types of ground straps as well, like how the shape, the end shape here, right? That can change and that can determine how conductive or what type of applications it's good for. The material the ground strap is made out of, look, this is an iridium plug, right? It's got a copper core, and they'll use copper cores because it's pretty conductive. But then you get down to the electrode type, which is typically iridium in this case, right? And the ground strap is usually some sort of nickel combination with some sort of alloy. It's usually a combo of multiple metals. And this is where a lot of people may not realize, right? There are different classifications for the ground strap. Now on the NGK 97506, this is considered an extended projection plug. And that means the ground strap is long, like really long. This is the longest type of ground strapped plug you can pretty much get, especially for the BMWs, right? So this is an extended projection. Now what happens when you start running really high power and really high boost, besides the fact that you've got to obviously jump the gap here and try and ignite that air-fuel mixture, right? You've got to worry about maybe things like detonation and pre-ignition hitting this ceramic and cracking the ceramic, or you've got to worry about things like, for example, this ceramic being able to dissipate heat well enough, and that comes down to obviously how hot or cold the plug is. But an extended nose ground strap means that this ground strap is sitting further in the combustion chamber, right? So I'll use a sleeve as a good example here. Pretend the cylinder head sits here, right? The spark plug might sit here in the chamber. The piston comes up and doesn't extend past the sleeve, right? The further that is in the chamber, the closer that is to the compressive forces and the heat generated by compression, right? And the problem with that is that when you have such a long and thin, thin bit of metal sitting inside of a very hot area, right? It allows it to get hot very quickly, right? Now, obviously, the heat track starts from here, and it works its way down, and then it dissipates heat in the threading, right? So having good thread engagement in the cylinder head is absolutely crucial. But the longer this is, the harder it is to get that heat out, right? So a long-nosed or extended projection plug has the risk of this little end getting so hot it can cause things like pre-ignition, where it ignites the fuel before the spark even fires. Now obviously detonation, knock, super knock, that's different to pre-ignition, right? Pre-ignition is where the air and fuel is ignited before the plug fires, right? So having an extended nosed or extended projection plug can actually be very detrimental when it comes to performance applications. So basically, I guess the TLDR of something like this is we care about the heat range, we care about the gap, we care about the tip length or type, and we care about the metal shell extension, because the higher the metal shell extension, the more protection this ceramic has to things like pre-ignition and detonation, right? And then the plug type in terms of how hot or cold it is, as to whether or not the plug can dissipate heat quick enough to stay in one piece. They're the main crucial points, right? Secondary to that, obviously, yes, the material type like iridium, ruthenium, silver, etc. That all does matter, but most performance plugs are pretty much always going to be either iridium, silver, and according to NGK, possibly even ruthenium or ruthenium. I'm not sure how to pronounce that. So this is a good plug, but we would not want to be going over, like I said, 26 pounder boost on that plug. It is not optimal. Now you go for the N20. Well, what options do I have? Okay, so this is where we get into the fun stuff. This is a ruthenium, I'm not really sure how to say it, NGK plug. There are some obvious differences. So for starters, it does have a slightly different washer type. It is still a washered spark plug. The type of washer doesn't necessarily matter. It can, but it depends on the cylinder head design. In this case, for the N20, it is fine. It still will seal. I mean, obviously, you'll notice the hex type is different. So it's not a multi-hex like this plug, but it is still a 14mm socket. So you can still use your existing spark plug sockets. Another change you may notice is that this has got a ribbed, you can hear it, it's got a ribbed ceramic at the top. Now, that is really, really helpful for things like flashover prevention, and I'll get into flashover a little bit later. But flashover pretty much can ruin plugs, but can also prevent the tip of the plug from firing. Now, this is actually an 8 heat range plug, okay? So it is actually the same heat range as this plug. This plug, it has the same thread dimensions, it has the same thread length, right? It is virtually a good replacement plug. However, the difference with this plug, right, is that the firing point, which is basically the tip of this electrode, sits around about 2.7 millimeters further away from the piston or higher up in the chamber than this does. Now, that's not a bad thing. It's good because you're removing the projection point or the tip length. You're removing it further away from the compression and the heat that's generated in the chamber. So that's definitely a good sign, right? Number one, tick, yep. So we have less chance of this tip getting hot and causing pre-ignition. Number two, this is actually considered a projection-based plug, not a extended projection, which you can sort of tell. Look at the ground strap differences. I mean, it is a lot less. I don't know if you can see that on camera. Not sure if you can see that, but it is a little bit lower, okay? It's not by much, but NGK classify this as a projection-based plug, not an extended projection. Now, specifically with this ruthenium plug, it's got a PSP-based ground strap, and you don't know if you can see it on the camera, but there is, let's see if we can get close. Might be hard to focus, but there is a very small and fine on the end of this bit here of the ground strap. On the very end of it, there's a very small and fine little bit of material. And the reason why they do that is because it creates less resistance to be able to create the spark, for the spark to jump. It's apparently NGK recommend a tip like this for turbocharged and boosted engines. It is an 8 heat range plug. You will notice that the ceramic is smaller around the electrode. You'll notice the electrode is not protruding as much from the actual ceramic, unlike this one where it protrudes quite a bit, right? But it is an 8 heat range plug, and you can sort of see in here, you can see, let's see if it's on camera. See if it's on the camera. You can sort of see in here just how far down the ceramic goes before it connects with the body of the plug and dissipates heat. So it's an 8 heat range plug. It does work, but it only works on the factory coils, and I'll explain why. Factory or the PR, Precision Raceworks coils, basically any coil that supports this type of connection, it will work on. Now, in terms of what power this could handle, look, it is still unfortunately restricted by the fact that it is an 8 heat range plug. It does have a little better metal shell extension or shell coverage of the actual ceramic, so it has a little bit better protection than say this one does for the ceramic for pre-ignition and knock. Really, a plug like this is just, it's a better plug than this. It doesn't use iridium, it uses their ruthenium or whatever it is, which is supposedly a better conductor. And it has also, with this PSP ground strap, it's supposed to have a better, more uniform and more efficient ignition pattern, which means overall, it wouldn't necessarily say that you're going to make more power, you're just going to get a more efficient burn, apparently, according to their marketing, for a plug like this. So this does work in the N20s, but still in those high boosted applications, because of the fact that it's an 8 heat range plug and there are no 9 or 10 heat ranges for a plug like this, we wouldn't be using it really over that 26 pound mark. It is still restricted. All right, now let's get on to the fun stuff. I'm going to talk on obviously the N20s, which I've already been doing, but I'm going to talk on the B48 shortly. This is a Brisk spark plug. This is actually a Brisk spark plug for an N20. All right. This is their racing series of plugs, which uses a silver electrode, not an iridium, not ruthenium or whatever they call it. Now, it does have a thicker electrode. Now, the thicker or larger diameter electrode does necessitate, according to some spark plug manufacturers' specs, compared to, say, a thinner one, it does create a less efficient burn than, say, a thinner one does in terms of the ignition pattern. However, when you have a bigger one like this, you are able to actually jam more energy through it because you're less likely to burn this out, right? So you've got a bigger electrode. Your gap, which you can probably see, the gap on this plug is really tight. So this is considered a projection-based plug. Look, this is more in line with a projection. I'd sort of argue that's more of closer to an extended projection, but look at the differences in the ground strap length. Massively different. So the spark plug gap on this plug here is only 16 thousandths of an inch, right? Which translates to only 0.4 millimeters. It is a very thin gap. Now, again, you'd probably sit here and be like, you're running an upgraded coil, why is the plug gap so tight? Look, either way, it's just making it easy under highly boosted applications to allow that spark to jump the gap. You will notice, look how this is a 9 heat range plug in NGK terms. In the Brisk terminology, it's 10, but it's a 9 for NGK equivalency, right? So this plug here, as you can see, we've got great metal shell extension. That ceramic is completely protected by this metal shell. So it's got great detonation and pre-ignition characteristics. The ceramic, you can sort of see it. It pretty much almost immediately joins to the body of the plug, which allows for great heat dissipation. It's also silver, which according to Brisk is, more conductive over iridium, etc. But overall, this is a 100% compatible plug. So this does work on stock coils because of the end. It does work with the PR, the Precision Raceworks coils for the N20. This would be the plug that you would want to use going above 30 pound of boost. If you're using the B48, 58, N63 coils, the plug is not supported because the top here is different. The actual electrode here uses a different, needs to use a different connector, which according to the industry is labeled the VW cup connector or terminal, apparently. So this is just the standard terminal for the N20 or electrode, however you want to call it. Officially, it is considered a terminal. The ceramic here, standard design, and this is a multi-point 14 mil hex, right? In terms of thread reach and stuff, it is a little bit similar. It's they use a slightly thinner washer. It works out to be about 0.1 to 0.5 millimeters less thread reach than the OEM N20 plug, but the physical firing location in the cylinder is actually, if we get these two plugs here, see if I can get this on camera, it is actually substantially lower. So to give you an idea of how much higher, well, lower, higher, but how much higher this plug sits in the chamber, right? I've measured it for you. So the measurement chain is roughly 3.6 millimeters. That means that this plug's firing location sits higher up in that chamber by 3.6 mils or thereabouts. So when you're moving that firing point, you're obviously pulling the plug away from more heat and more combustive forces, but you can affect the ability of this plug to ignite the DI fuel mixture, because the plug position matters very, very, very importantly when it comes to DI cars. They position the plugs and they position the injectors in the right location so that the atomized fuel and the air is ignited at the most optimal point for peak efficiency. Now, that can, in some instances, affect performance in terms of power, but negligible here. What it really does promote is part load and cruise efficiency, right? So when you move that plug further up, you're gonna get a little bit shittier cruise and part load efficiency from the air fuel mixture being, unevenly burnt, or the burn pattern being a little bit off. But under high boost and high compression, it doesn't really matter. It's fine. You can go further up, right? And I'll show you, we've got an example here of something that's 6 millimeters of difference over the OEM N20. That's 6 mils. This is considered a surface gap plug, and you can pretty much see you can see here that the electrode, the ground strap is basically welded to the thread area, and it is incredibly small. And that's a 10 heat range plug, right? So this is a great plug. And it is technically compatible with the N20 cylinder head. However, when we tested this, the ground strap pretty much almost melted off. So I would say it is not designed for DI engines at all. I talked to NGK and they said that they don't think that the plug is really designed for a DI sort of setup, given the way that the fuel and air mixes in the cylinder and how it's designed to burn. It did run. It was a little bit hard to start, especially on cold mornings, and under idle it could be a bit rough, just purely because of where that ignition point sits. It's quite literally, if you look at the cylinder head, right, it's gonna be hard to demonstrate this, but it pretty much sits literally in line with the top of the cylinder head. It doesn't protrude down or anything. It's literally in line. So it can be a bit hard. Now this has got a 28 thousandths of an inch gap on its factory, so it is a higher gap. So look, this is ultimately the better plug to go for if you're running those coils, or if you're in a high boosted application trying to run factory coils, which you can sort of get away with at 30 pound of boost, give or take, depending on the plug gap. Right, so obviously, yes, it does change the location, as I've just gone into detail, but in a performance application, it's really negligible, because you want any sources of pre-ignition, like a plug tip, for example, to be further away from that and being able to more easily dissipate the heat. And on top of that, you're gonna want to really maximize plug efficiency for performance rather than part load and cruise possible efficiencies. Alrighty, moving on to B48 Generation 1. Now, this was the first one that came out with a slightly different plug. So, this is the VW Cup terminal, apparently, according to Brisk anyway, that's what they classify it as. It's virtually not that different. It's an 8 heat range plug. It does have a bit more metal shell extension protection for detonation and detonation and pre-ignition against the ceramic. Unlike the N20, it's considered a projection plug, not an extended projection. It is iridium. The electrode here is, I believe, it's 0.6 millimeters versus the 0.1 millimeter of the N20, so it's a little bit thinner, which allows for a more efficient burn, but as I'll show you as we go through the BMW range, they seem to chop and change that a bit. The stock gap for this plug is, the stock gap for this is 0.75 millimeters, which comes in around about 30 thousandths of an inch, right? So this is the stock Gen 1 plug. Look, it's really no different. It's got the same multi-point 14 millimeter socket there, the same type of washer. Yes, it's not a copper-based washer. It looks like a stainless washer, but it's the same thickness. The thread reach is basically identical to the N20. It's just overall a slightly better designed plug. So in theory, yes, this plug is compatible with the N20. However, this plug does sit 1.6 millimeters or thereabouts higher up in the cylinder over the factory N20 plug. Still an 8 heat range plug, but it does work. It is compatible with, say, the BXX based coil upgrade kits. So it's definitely a good swap out plug if you're running those types of coils. Again, it's still 8 heat range, so you are limited, but look, we haven't seen on the B48s anyway, specifically speaking about the B48s at this point, these plugs tend to be fairly reliable up to around 30 pound of boost. They can run over that, but we typically end up seeing plug life extremely shortened at that point. So I typically don't really recommend going above 30, 32 pound on these plugs if you're going to daily the car. I mean, in general, there are options to upgrade these now to better plugs. So it's either you change plugs every couple of weeks or months or whatever it is, or you just get a better plug. However, this has been a fairly reliable plug in the B48 space. We don't gap these plugs, as I mentioned. You don't need to. The factory coils do generate plenty of energy to jump this gap. Okay, so we don't need to gap them. If you were having issues at really high boost and the coil output, maybe it's not enough or whatever it is, then yeah, you could consider gapping the plug. Now, that's the B48 stock plug. This is a Brisk Racing version of the stock plug. It is the same heat range, so it's classed as a 12 heat range. This is an 8 heat range NGK, so they're the same NGK equivalent. It's got the same terminal, same ceramic design, same multi-point socket design. It's basically the same in terms of the thread reach and whatnot. It does sit differently though in the cylinder. So this plug sits around about 1 to 1.2 millimeters higher up in the cylinder than the factory plug does. It runs an 18,000ths of an inch plug gap, right? Obviously you can see the ceramic protrudes against the metal shell a little bit. So it's got standard sort of, detonation protection, etc. It's an 8 heat range equivalent in NGK world. It's a silver racing plug, so it's supposed to have better ignitability than the factory's iridium plugs. So it is a capable swap out, but you are still limited by the heat range of this plug. So it's more just a suitable replacement NGK plug if you wanted a slightly better plug. Where the real shiny stuff comes from this one here. This is the 10 heat range in Brisk's terminology, which is a 9 heat range in NGK. This will definitely handle 40 pounds of boost. I mean, again, 8 heat ranges in N20 and B48 world have done 40 pound of boost, but they don't tend to last very long at that sort of boost level. So running to something like this, the plug will last longer. It'll just be a better plug. Now this is a 16,000ths of an inch plug gap, just like the N20 version. It is incredibly small gap, which is about 0.4 millimeters, whereas this is 18th thou, so about 0.5 of a millimeter. It does sit 2 millimeters higher in the cylinder than the factory plug does, so it's an additional 0.8, 0.9 millimeters over the other heat range plug. It's a silver racing plug. Yes, it does have the thicker electrode, but it is considered a projected type of plug. But you can definitely see, I mean, especially if we start comparing it to the stock N20 plug, look at how much difference there is in that ground strap. Look at that. So it's definitely the better plug. Now, a plug like this is definitely compatible on an N20 with the BXX N63's type of coil upgrades, and it's definitely a plug for 40 pound of boost. 100%. This is the plug to be using. This plug, yes, but up to 40 pound of boost, yes, but you're really going to be limited here on the coil pack energy capabilities as to whether or not this type of plug would be more suitable than, say, this version of the plug. But these are definitely your 40 pound of boost plugs. Whereas really 26 pounds for the N20, we're having problems with up to 30 pounds here. Again, this is a suitable replacement on the N20 as well if you're going to be running those B48, B58 style coil packs. Again, this is also another suitable N20 replacement plug, but really 26 pounds of boost is probably where I'd sit that one at anyway. For long-term reliability, again, both those plugs in the N20 may do more than 30 pound of boost for a bit, but I haven't typically seen these plugs last very long when we were testing the plugs out. So that's our B48, that's our N20 stuff sorted. Now the B48 Gen 2s, these are an interesting setup for a variety of reasons. Rightio, so we have 3 plugs for the B48 TU or B48E or S58, B58 TU, B58. I might have the order a little bit wrong for these two, so forgive me, but we'll talk about them. BMW released multitudes of these plugs because they've made revisions to them, and the revisions arguably aren't much, but basically it is no different to the B48 Gen 1 plugs. However, it does sit a little differently in the chamber. Now, for example, if you were to put this plug or any TU-based plug inside of a Gen 1 motor, right, you would be sitting at about 0.35 of a millimeter further into the chamber, right? So that's something to consider. These are not really an upgrade for a Gen 1 plug. They could be considered a downgrade because they sit further down in the chamber, okay? So not ideal. I wouldn't be running them. However, where these plugs excel over the factory B48 Gen 1 plugs is look at the extended metal shell, right? They've got more metal shell protection against that ceramic for detonation protection and pre-ignition protection, right? Even the strap design is slightly more robust and it's slightly smaller. It's not as long, right? So that's better. That's going to be better for heat removal out of the cylinder, right? So you could, in theory, run this. And we were talking about 0.35 of a millimeter. It's kind of bugger all. It's, 0.3. It's like 16ths, thereabouts, 17 thousandths of an inch in terms of how much higher it is or lower it sits in the chamber. So yeah, you could still use it. But look, that's the main change they made. In terms of plug gap, the plug gap on this plug is about 0.8 of a millimeter. Sorry, it's 0.75 of a millimeter. And my apologies, it looks like in my notes, the C version of this plug came before the E version. So the C version, which is this one here, it has a 0.75 plug gap on it, right? The spark plug metal shell extension is much the same as the ceramic in terms of this plug here. I mean, look, to be honest, the differences between these two plugs is like minute. From what I've looked at, it looks like really the change was the plug gap on these plugs because the metal shell extension is basically the same in either plug. Everything about this plug is the same. Look, all of the plugs I'm talking about today have a resistor in the center. Like I said in the start, they, obviously they do have the VW cup based terminal, apparently is what they call it. It's the same washer, it's the same thread length, it's the same thread reach, etc. So they're basically the same plug. BMW just decided to change the plug gap. On the C version, the E version, they went to a 0.8 millimeter plug gap, which is about 32 thousandths of an inch off the top of my head, over the 0.75, right? So the 0.75 is a 30 thou plug gap. So they increased the plug gap. That's up to them. Then, in late 2022 or early 2023, they replaced the plug again with a new style of plug. They've changed the ground strap design a little bit. You can see the metal shell extension is actually higher. It's 0.5 of a millimeter higher now. They've also pushed the ceramic further down so the electrode is actually more exposed. So if you have a look, you can probably see this on the camera, right? The electrode is actually more exposed in that ceramic. The ceramic sits down. These are all 8 heat range plugs. They're not a different heat range, but they've obviously added more detonation protection to that plug. Then they've gone and changed the plug gap again, and it's been set back to a 0.75. So it's actually a smaller gap again. Now, I'll talk about this one briefly. Now, obviously, these plugs are all compatible with the BXX coils. I don't think that's pretty self-explanatory. This is an N63 TU3 plug. This plug, despite being an 8 heat range, it's a Denso plug. It's not NGK. Apparently, they chose not to use NGKs for that engine. Despite the fact that this engine is basically the same or similar technology style to the B48, B58 engines, it has the same terminal. There are some differences. I mean, for starters, the terminal does not have a recess. It has a flat top, which is interesting because the reason why you have the recess is because the spring portion of the coil boot sits into that terminal better and creates a better contact. Whereas this one, the spring just sits on top of it. Not super great. The washer and plug reach and stuff like that, it's all much the same, except this, they classify this as a projection plug in Denso world, but this is very much on par with an extended projection plug like the N20. Like, virtually the same. It has bugger all metal shell protection against the ceramic. It's an 8 heat range plug. In Denso's terminology, I think it's like a 6 or something like that heat range. I don't know off the top of my head, but it's an NGK equivalent to an 8 heat range. It's a plug. It works. Would you ever use it? No. Would you even use it in an N20 with the BXX coils? No, but you could. Why you would, I don't know, but just thought I'd talk about that. Now, when it comes to wanting to run, an upgraded plug in the TU motors, right? you pretty much would be wanting to run the B48 Gen 1 upgraded plug from Brisk. It does sit a bit higher in the cylinder. It's roughly 2.35 millimeters higher in the cylinder, but it is going to be the better plug to run in general, period. It would be the plug that I would use regardless. So definitely a plug I would recommend people use at high performance in the Gen 2 engines. Now, I will briefly touch on this plug. This plug is an Audi plug, actually. It's not a BMW-based NGK plug. It is a 9 heat range plug. It is virtually compatible with the N20 and the B48s. However, things that it suffers with is it does not have metal shell extension around the ceramic like pretty much all the other plugs I've talked about today in terms of B48 land. But it is a 9 heat range plug, right? And it does bolt on and plug and play. Obviously, it's got the VW Cup terminal, which would restrict you to those BXX coils. You cannot run an N20 coil on this. It will just, or all those precision ones, it just will not create really any contact to the plug. So it's definitely a worthy contender in terms of the plug. Now, let's get into why the terminal type matters and why the ceramic is different and what flashover is. Because we recently just had, and I'll show you some photos of what flashover is in a spark plug. So, if we have, say, this plug, and we use a BXX coil, so in this case, this is an N63 T3 coil boot. Rightio. So if you go and use, and I'm using an N63 coil boot here, the boots between the B48, B58, and the N63 boots, they're much the same. The real difference is, besides the length, the tip here is smaller on the actual contact spring in the B48 coils. B58 coils is smaller than the N63, but doesn't matter. We're still going to illustrate the same point. If we go and shove this plug in here, so we can get the lighting on this right. If we go and shove this coil in here, this plug in here to this spring, right? We are only making contact specifically on the top of that terminal with that spring, which sounds all well and good, right? Now, a coil boot and the plug are supposed to sit like that. The boot needs to come down to the hex head, right? And the reason why is because you want to insulate all of this ceramic, right? And the reason why you want to insulate it is because what you don't want is you do not want a spark to jump from there and short out here. Because if it shorts out here, this does not fire, right? So flashover occurs when the spark jumps from there and bridges out here. And you go, well, how does that happen? Okay, well, for starters, right? You might have some crap in here, some debris of some sort stuck between the ceramic and the boots, because your boots are dirty, or maybe your spark plug installation socket was dirty and it's left it on the plug. That is conductive and allows that spark to jump from there to there. Another thing, right, and that can actually cause cracks along the ceramic, mind you, and you have to replace not just the plug, but you got to replace the boot when that happens. Another thing can be if the terminal is not insulated properly and the contact pad is not great on the terminal, right, it causes a bit of resistance. So under high energy outputs, that terminal is on the spring side of it is going to want to find the easiest path to short out, right, or create a connection, a complete circuit. And if it's not going to be the terminal of the spark plug, it's going to be the terminal of the actual body of the plug, right? So another thing too is that, well, how does that happen if it's in the insulation like this? Well, if you're using the wrong plug, and you might be able to see this on the camera, we'll see. You notice there's a bit of an air gap around that terminal, right? And then it's not until up here, up where my finger is now, that the actual insulation 100% touches that terminal and actually creates a nice good insulation on that plug, right? And that's a good indication of a plug that is not compatible with the coil, because you've got that air gap there, all right? You've got nothing to insulate against the actual plug. And if you've got a bit of crap here, or let's say, you know, maybe the coil doesn't sit right, so you've got that sitting like that, or whatever it is, you've got it sitting like that, all you're doing is creating an opportunity for that high energy coil pack to jump and bridge a connection, whether it's to this or to the body of the cylinder head or whatever. Now, if I go and put the right plug in, right, here's the difference. If you can see that on camera, that insulation is 100% shaped and form fitted to that ceramic and that terminal, right? It is 100% creating a great seal and great insulation on that body of that plug. Not to mention, this is why I said the N63 Denso plug is a bit of a weird one, right? We take out the spring part of the coil. When it goes into that terminal, right, it goes in and it sits in there. It literally sits inside that terminal. If we get the Denso plug, it just sits on top. All right, it's loose. See, I can move it around. It sits on top, and you've got bugger all of a contact patch. Right, when you've got this in here, look, I can't easily move that. It's locked in there. Right, it's not just contacting with the tops; it's contacting with the sides as well. So definitely a better plug for this type of coil. So there you go, N63 people, if you're watching this. But yeah, that's Flashover, and that will kill your plugs. You will need to replace the plugs, and you need to replace the coils. You can try and clean the coil boots out. Like, see all this, I don't know if you can see it on the camera, but all the dirt and crap that's in there, that's all going to create an opportunity for those plugs to then create a circuit elsewhere. As we were talking about with the Flashover, here's a good example of an N20 plug that's had Flashover. So you can see how it's arced across the ceramic to the hex head. That's actually like a crack through the ceramic. Like, that's permanent damage. It's not just a bit of like carbon. That's proper damage. So it's arced and it's just done that. And in the coil boot, you could actually see that arcing through the coil boot as well. It left a mark. Now, let's briefly talk about gapping your plugs, right? I've got a spark plug gapping tool here. Now, this tool only closes the gap. It will not open and gap up. There are other tools, I'll try and dump a photo here somewhere, that allows you to open the gap up if you need to, although weird unless you've gone too far. Now, the tool I'm using is just one from Mode Auto Concepts, or whatever they call themselves. Every major strike on this top is 1.1 of a millimeter. Okay, so 0.1, you know, 0.1, 0.1, 0.1. All these ones here are half of that, or a quarter of that, or whatever it is, right? So this is the tool, but you need more than just the tool. You also need feeler gauges, right? Because you need to measure your distance. So if we wanted to gap this Denso plug, and I'll use this as a sacrificial piece, I screw it in, right? I screw it in until they join each other, right? And we know, let's say the factory gap on this plug, according to my notes, is it's 0.7 of a millimeter, right? So that's roughly 28 thousandths of an inch. If we want to go down to 18 thousandths of an inch, right? I'm going to tighten up the plug until it's nice and like tight. I don't want to go too tight because it'll start to actually compress it. We want to just go till it's, you know, a bit of resistance. And we go, okay, we know that is, you know, 0.7 of a millimeter. I want to bring it down to, let's say 0.5 of a millimeter, right? So 0.5 means that I need to just make sure these are lined up. All right, make sure that's tight. Sorry, I've been doing this a bit off camera here a bit. All right, so we know that it's all right. Okay, let's go. We want to go down to, what did I say? 0.5 of a millimeter, so 18 thousandths of an inch. So that means that I need to go from 0.7, I need to go down to 0.6, so that's 1, down to 0.5, that's 2, and that's pretty much all I need to do. So I only need to turn this I need to go to here, right? Make sure that's right. Yeah, so 1 major strike, 2 major strikes, so I just need to go to this one here. And it's going to be a bit tight, obviously, because you're compressing the metal. That effectively has just closed that gap up. And I don't know if you can see that on the camera, but the ground strap is definitely a bit more bent in than it was before. Now, it should automatically bend it, and we shouldn't have to hold the pressure there for long. I'll take this plug out. All right. We know originally it was 0.7 of a millimeter based on our pre-existing steps, pre-existing measurements. Alrighty, so I'm going to obviously find the feeler gauge I want. So this is the 0.5 millimeter, or 20 thousandths of an inch, sorry, not 18 thousandths of an inch. And we're going to put it into the tip of the plug, right? And if it goes in nice and easily, we know that's right. Now that feels a bit loose, so let's go up one just to make sure. So we'll go for a bit of a thicker one, right? So here we go. This is 0.6 of a millimeter, so that's 24 thousandths of an inch. All right, so we'll just check that. Yep, that goes in. Okay, that doesn't really look like it really did much. Okay, so you basically just keep checking the measurement and readjusting this as required to get this at the gap that you need it to be at, okay? So you check, measure, you know it's the right feeler gauge, or like as in it's too tight or whatever, because you don't want to force it, right? You don't want to force it in at all. So let's just find the 0.7 millimeter ones. So yeah, here we go. Look, it just goes in. So you'll know it's right because it'll just go in and it'll just come out. You got to be really careful here because you don't want to scratch the tips, because you'll get rid of the precious metals that are on either tip. And you just want to go in. You might have to get the right angle. You get the wrong angle, it'll get jammed. And then you just do that, and then boom. That's how you do your gapping. For spark plugs, if you need to open it up, well, you've got to buy a different tool to pretty much pry that gap open. Old school people used to just whack it a few times and measure it, but you'd actually risk damaging and cracking a lot of the plug by doing it. So use a proper gapping tool. Make sure you measure your gap properly. All right, do it once, do it right. That's it for today's spark plug video. Hey everyone, and thank you again for watching the video. Look, I hope it wasn't too bad. I hope it wasn't too boring. I hope you guys learned something from it. The purpose of today's video was to hopefully teach you a little bit about spark plugs for cars in general, but also BMWs. So without further ado, please like, subscribe, and stay in touch with us. If you want more content, let us know. Tell us what content you want, and I'll try and make it.